The German engineer paused, his breath forming a small cloud in the chill April air of 1943. He ran his hand slowly along the cold, olive-drab hull of the captured American tank. It felt different. Visually, it was unimpressive compared to the angular menace of a German panzer, but his tactile sense told him something else. Something was wrong. Not wrong with the tank itself, but wrong with everything he had been told by the propaganda machine about American manufacturing. He was standing in the heart of the Third Reich's military complex, yet he felt a sudden, chilling premonition of defeat. It was April 1943. A turning point in the war, though few realized it yet. The tank, sitting silently in the muddy expanse of the Kummersdorf proving grounds, had been captured in the burning sands of Tunisia just 2 months earlier. Its serial number was stamped clearly into the metal, USA 306-7641. The American crew had affectionately painted a name on its side, War Daddy 2. To the German High Command, however, this was not a pet, it was a specimen. They demanded a complete forensic evaluation. They wanted to know the Sherman's weaknesses. They desperately needed firing tables, showing exactly where their anti-tank gunners should aim to kill it. The engineer had spent 3 exhaustive weeks examining every bolt, every rivet, and every wire. And what he found wasn't weakness. It was a terrifying efficiency. He ran his fingers over the welds again. They weren't just strong, they were clean, uniform, machine-made. There was no artisan's mark here, no individual craftsman's pride. It wasn't just a manufacturing philosophy that terrified him. It was the sudden, crushing realization that while Germany was busy crafting intricate masterpieces, America was simply printing tanks. To understand the magnitude of this discovery, one must look back to how War Daddy 2 arrived here. The tank had been captured on February 22, 1943, merely 8 days after the disastrous Battle of Sidi Bouzid began. That battle had been a humiliation for the inexperienced American forces. Hardened German panzers, veterans of the Eastern Front and the Desert War, had smashed into the US 1st Armored Division with coordinated ferocity, sending them reeling back in panic toward the Kasserine Pass. The tank belonged to Company G, 3rd Battalion, 1st Armored Regiment. During the utter chaos of the retreat, amidst the smoke and the screaming of radio commands, the crew had abandoned it. Why? The mystery remained. Maybe they ran out of fuel in the vast desert. Maybe they took a non-penetrating hit that threw a track. The records are silent on their fate. What the records do say, with chilling clarity, is that German recovery teams found the Sherman intact. It sat there in the desert, a prize waiting to be claimed. And unlike most captured enemy tanks, which usually required extensive repairs to get moving, this one started on the first try. The engine roared to life without hesitation. The Germans didn't just tow it, they drove it. They drove it over 200 miles to Tunis, 4.5 days across the punishing, heat-blasted desert terrain. There were no breakdowns, no mechanical failures, no overheating. They loaded it onto a ship, navigated the dangerous Mediterranean waters, and sent it deep into the heart of Germany. High Command wanted their absolute best engineers to tear it apart. They expected to find flaws that would bolster morale. Instead, what those engineers found would fundamentally change how they understood the war they were fighting. Kummersdorf was not just a garage, it was the brain of the German war machine. Located 20 miles south of Berlin, hidden among pine forests, it was Germany's premier weapons testing facility. This was the birthplace of the German rocket program, the laboratory where the terrifying V weapons were conceived, and the testing ground for every major Wehrmacht weapon system. The most brilliant mechanical minds in the Reich worked here. These were the men who had evaluated captured Soviet T-34 seconds in 1941, panicked by their sloped armor, and helped design the Panther tank as a response. Now, in 1943, they had their hands on their first functional American medium tank. Initial expectations were incredibly low. German intelligence, fed by their own propaganda of Aryan superiority, had dismissed the Sherman as a mass-produced, inferior design. They viewed it as a toy, thin armor, a weak gun, built by a nation of shopkeepers who had never fought a modern tank war. The engineers approached the Sherman with the arrogance of master artisans inspecting a cheap, mass-market knockoff. They expected sloppy welds that would crack under pressure. They expected brittle steel full of impurities. They wanted to laugh at the crude American attempt to build a war machine. They had their pens poised, ready to write a scathing, mocking report that would make High Command smile and reassure the Führer. They started their inspection with the armor. They measured every plate with micrometers, calculated every angle of incidence. They stenciled the numbers directly onto the olive hull in stark white paint. The result was underwhelming. The armor thickness was adequate, but certainly not impressive. It was 51 millimeters on the front hull, 38 millimeters on the sides. A German Tiger tank could punch through that protection at ranges over a mile. The engineers scoffed. But then, they opened the rear engine compartment. The Continental R975 radial engine sat in the rear of the hull, looking strangely out of place, like an aircraft engine that had been dropped into a tank. Because, as the engineers realized, that is exactly what it was. The Americans, in their haste to mobilize, had taken a proven, existing aircraft power plant and adapted it for armored use. It produced 400 horsepower and was air-cooled. It was designed for absolute reliability at high altitudes where mechanics couldn't reach it. If it wouldn't fail at 10,000 feet, it wouldn't fail on the ground. German engineers noted the power-to-weight ratio immediately. The Sherman weighed 30 tons. The engine gave it nearly 13 horsepower per ton. In comparison, the new German Panther weighed 45 tons, but, despite its massive 700 horsepower engine, only achieved 15.5 horsepower per ton. The Panther was barely more agile than the smaller American tank, despite weighing 50% more and costing twice as much to build. But raw power wasn't what stopped the German engineers in their tracks. Any industrial nation could build a powerful engine. Germany built the best in the world. What impressed them, and terrified them, was the maintenance access. It was a masterpiece of user-friendly design. Every major component could be reached through large, easily accessible hatches. Oil changes took minutes. Spark plug replacement required no special tools, just a standard wrench. A mechanic with basic training, a farm boy from Kansas, could keep this engine running indefinitely in a muddy field. Contrast this with the German reality. German tank engines were complex beasts that required factory-trained specialists for routine maintenance. The Maybach HL230 in the Panther, while powerful, had known cooling problems that frequently caused catastrophic engine fires. Replacing a Panther engine was a nightmare. It required a heavy crane, a specialized workshop, and a full day's work by a team of experts. The Americans had built a tank that could be serviced in the field by anyone. The Germans had built prima donnas that needed to be shipped back to factories for care. The engineers kept examining, digging deeper into the machine, and it kept getting worse. It was the sound that eventually stopped them, or rather, the lack of it. When they ran the powertrain, the German engineers were accustomed to the screaming whine of spur gears fighting against friction, the soundtrack of the Panzer divisions. The Sherman, however, hummed. One engineer called his colleagues over, unable to believe what his ears were telling him. He pointed into the gearbox. Herringbone gears. They were looking at precision-cut helical teeth that meshed smoothly under load. These were the kind of gears that lasted for thousands of miles without wearing out. German tanks almost exclusively used spur gears, straight-cut teeth that were cheaper to manufacture but incredibly loud and wore out quickly under the immense stress of combat driving. The reason for this disparity was simple but devastating. Herringbone gears required complex machining and specialized gear-cutting tools that Germany simply lacked. Furthermore, the tooling required tungsten carbide, a strategic material in critically short supply due to the strangling Allied naval blockades. Germany had been forced to revert to spur gears to save manufacturing time and reduce tooling wear. The result? The Sherman's transmission could handle 3,000 miles before needing an overhaul. The Panther's final drive had an average lifespan of around 100 miles. Not 100,000, just 100. A Sherman could drive from the beaches of Normandy to the streets of Berlin under its own power. A Panther could barely make it from the rail yard to the front lines without snapping a gear. The engineers documented everything, their arrogance slowly turning to dread. But they weren't prepared for what came next, inside the turret. Attached to the mounting of the 75mm gun was a small, unassuming box. Electrical cables ran from it to a gyroscope positioned near the gunner's seat. It was a gun stabilizer. The Americans had put a sophisticated gyroscopic stabilization system in a mass-produced tank. The German engineers were astounded. They had experimented with stabilizers in laboratories, but had never managed to miniaturize the components enough for practical tank use. The precision required was beyond their current mass manufacturing capabilities. The American Westinghouse system wasn't perfect. It only stabilized in the vertical plane and didn't allow for true shoot-on-the-move accuracy in the modern sense. But it did something far more valuable in the chaos of war. It kept the gun roughly on target while the tank bounced over rough terrain. This meant the gunner could fire accurately within seconds of the tank coming to a halt. German tanks, with their heavy, unstabilized guns, needed 10 to 15 seconds for their suspensions to settle and the gunner to reacquire the target before they could fire. In a tank duel, 10 seconds is a lifetime. It is the difference between life and death. The first accurate shot usually won the engagement. The Sherman could get that shot off before a German tank had even stopped bouncing. The Germans examined the gyroscope and servo motors with envy. They calculated what it would take to replicate the system. The answer was despair. They couldn't. Not with their current industrial base, not with the materials available, not with the precision manufacturing they had left. And yet, they still hadn't discovered the worst part of the story. In June 1943, War Daddy II was transferred to Hillersleben for a grand demonstration before the High Command. The generals didn't want a boring reliability test, they wanted a show. They wanted theater. Senior officers from across the Wehrmacht gathered to watch. Men who controlled armored production priorities. Men who would decide whether to keep building Tigers and Panthers or change course. To test the tanks, they set up a climbing test. A steep, punishing 30-degree slope of loose, shifting sand. The Panther went first. The sleek German Predator roared up the hill effortlessly. Its wide tracks distributed its weight perfectly, biting into the sand. Its powerful engine never strained. It crested the hill like a champion. The generals smiled, nodding to one another. This was German engineering. Then came WWII. Its narrower rubber block tracks, designed for long road marches rather than loose sand, slipped immediately. The engine whined in protest. The tracks spun uselessly, digging holes in the dune. The tank slid backward, unable to find traction. The Sherman failed to climb the hill. The generals applauded. They laughed. The demonstration had proven exactly what they wanted to believe. American equipment was inferior junk. The failure on the hill at Hillersleben was a disaster. But not for the Americans. It was a catastrophic disaster for the Germans. The generals looked at the hill and saw a victory for German technology. The engineers, however, looked at the transmission and saw a warning. The Panther had won the sprint, but the engineers knew it would never survive the marathon. While the Sherman couldn't climb that specific sandy slope, it had just driven over 200 miles across the Tunisian desert under its own power to get captured. It had traveled across the ocean and driven to the testing grounds. That was a feat the Panther could rarely match without breaking a final drive or catching fire. The hill climb validated every wrong instinct the German military had. It convinced them to keep building high-performance thoroughbreds instead of reliable workhorses. The engineers who had spent weeks inside WWII's engine compartment knew the truth, but they were silenced by the applause. They had just watched their generals cheer as the Sherman slid backward, blind to the fact that the American tank's failure on the hill meant nothing compared to its success in getting to the hill in the first place. And then, Albert Speer came to see for himself. Albert Speer was the Reich Minister of Armaments, the second most powerful man in the German economy. He controlled all war production. Every tank, aircraft, and submarine built in Germany came under his authority. Speer had a reputation for cold efficiency. He was the technocrat who kept the war going. He had tripled German weapons production in 1942 through ruthless reorganization and streamlining. He believed German engineering could outproduce the Allies if properly managed. Photographs exist of Speer climbing onto WWII, examining it with a critical eye. He studied the secret reports. He talked to the terrified engineers. And he reached a conclusion that would haunt him for the rest of his life. Speer later wrote in his memoirs that reports from the front lines in Italy praised the Sherman's cross-country mobility. The American tank climbed mountains that German experts considered totally inaccessible to armor. The engine's power-to-weight ratio gave it superior agility on level ground compared to the lumbering German heavy tanks. But Speer understood the deeper, more fatal problem. Germany was building complex machines that required a dedicated rail network to move anywhere. America was building a mobile force that could drive itself to the front lines. Speer realized that no amount of German engineering genius could overcome a logistical philosophy that was simply better. The Sherman wasn't just a tank, it was a philosophy of war. American industrial philosophy prioritized three things above all else: reliability, maintainability, and mass production. German industrial philosophy prioritized only one thing: technical superiority and combat performance. American designers had made different, calculated choices. They accepted a less powerful gun because the 75mm was reliable and ammunition was plentiful. They accepted thinner armor because it reduced weight and improved mobility and fuel range. They accepted a simpler design because it meant faster production and easier maintenance for conscript crews. Germany couldn't compete with that. Not because German engineers weren't brilliant, they were, but because German engineers had optimized for the wrong things. They were building Formula One cars for a demolition derby. The men who understood this reality best weren't the engineers in Berlin, but the tank crews freezing in the mud of the Eastern Front. Alfred Rubbel commanded a Tiger I in the elite 503rd Heavy Panzer Battalion. He eventually became a tank ace with 57 confirmed kills. He knew exactly what German tanks could and couldn't do. His unit often used captured Shermans for recovery and supply duties because they were the only vehicles that always ran. Rubbel later compared the Sherman to a reliable civilian car. "You pushed the button and they started," he marveled. With the Tiger, there was always a ritual: checking fluids, preheating the engine, worrying about the transmission, praying the tracks wouldn't snap. The Sherman just worked. German tank crews loved their Tigers and Panthers times when times they worked. The problem was, they rarely worked. By 1944, German armored divisions reported operational readiness rates of merely 35 to 45%. More than half their tanks were broken down at any given time. American armored units maintained readiness rates above 85%. When the Americans needed tanks for an offensive, they had tanks. When the Germans needed to counterattack, they had repair orders. The numbers told the story that German propaganda tried desperately to hide. The Normandy campaign in 1944 proved everything the Kummersdorf engineers had feared a year earlier. During the desperate retreat from France, roughly half of all abandoned Panther tanks had been destroyed by their own crews after mechanical breakdowns. They hadn't been hit by enemy fire, they had simply stopped running. Imagine the frustration, the rage of a German panzer crew. You have the most powerful gun on the battlefield. You have the thickest armor. You are the elite. But you are standing on the side of a dusty road in France, watching your transmission smoke, holding a detonator to destroy your own tank, while a column of inferior Shermans drives past you to win the war. They didn't lose because they were outfought. They lost because they couldn't even get to the fight. The statistics from the Battle of the Bulge were even worse. By late 1944, 60 to 70% of German heavy tank losses were non-combat related. They were lost to fuel shortages and breakdowns, not American gunfire. The engineers at Kummersdorf had seen this coming in April 1943. They had tried to look past the showy hill climbing demonstration at Hillersleben and focus on what actually mattered: the internal components, the manufacturing philosophy, the brutal mathematics of reliability. They had documented every advantage the Sherman offered. They had written reports explaining exactly why American mass production would win the logistics war. Nobody had listened. The generals had watched the Sherman fail on a sandy slope and walked away confident that German engineering was superior. Ultimately, Germany couldn't adopt the American manufacturing philosophy for reasons that went far beyond engineering. It was a systemic failure. The strategic materials weren't available. Herringbone gears required complex tooling that Germany lacked. Precision electronics required copper and rare earth elements that were unobtainable. Allied blockades had effectively cut Germany off from global supply chains. Furthermore, the production culture couldn't change fast enough. German factories were organized around skilled craftsmen who hand-fitted components, treating each tank as an individual project. American factories used interchangeable parts and assembly lines, treating tanks like automobiles. Converting one system to the other would take years Germany didn't have. But perhaps most significantly, the Nazi ideology got in the way. German engineering was supposed to be superior by definition. Admitting that American mass production techniques were better contradicted everything the regime believed about Aryan technical superiority. To copy the Sherman was to admit the enemy was smarter. So, Germany kept building Tigers and Panthers. They built magnificent machines that spent more time broken down than fighting. They built technical marvels that couldn't compete with the tidal wave of American quantity and reliability. Germany remained trapped, bound by an ideology that demanded perfection and an industrial base that could no longer afford it. The final tally was staggering. America built 49,324 Sherman tanks during the war. Germany built approximately 6,000 Panthers and 1,347 Tigers. The production ratio was nearly 8-to-1 for medium tanks alone. But the raw numbers don't tell the whole story. American tanks actually worked when they reached the front. A Tiger might be able to destroy 5 Shermans in a single engagement, a terrifying tactical victory. But there would be 6 more Shermans arriving tomorrow, and the day after that. Meanwhile, the Tiger would be broken down on the side of the road, waiting for a transmission that wouldn't arrive for 3 weeks because the rail lines had been bombed. The mathematics were brutal and unforgiving. German tankers achieved kill ratios that would have won any other war in history. But this war wasn't about kill ratios, it was about logistics. War Daddy 2, the tank that started on the first try, had shown the German engineers exactly why they would lose, long before the end came. It showed them a tank that started when you pushed the button. It showed them a transmission that lasted the life of the tank. It showed them an engine that any mechanic could service in a field. The lesson was harsh but undeniable. Reliability beats perfection. Availability beats capability. Working beats superior. Every single time.